Now we will start the first part of the diesel engines. Okay? Diesel engines, we know this. First, before we start with diesel engines, we in the series of combustion last semester we studied the gasoline engines. Okay? We studied everything about them, about injection systems and their operating cycles, their advantages, disadvantages. We talked about all of this. Okay? So, in this subject, we will talk about the diesel engines, the diesel engine types, their performance. We will talk about the fuel injection systems. We will talk about the differences between the diesel and the gasoline. I already mentioned that in the previous subject, the series of combustion, but I will remind you with this again. Also, we will discuss the emissions of the diesel engine. Okay? Diesel engines, they are mainly used in it's like transportation applications. It's for goods and large transportation applications. Okay, you can rarely find a passenger diesel vehicle. Okay, all the passenger vehicles, small passenger vehicles, are gasoline powered engines. Okay, or the cars, they are gasoline powered. Okay, some of them are diesel, but still you can't find lots of diesel cars for passenger usage. Okay, but if you start to increase the size of the vehicle, it's a van, it's a pickup truck, it's a bus, truck, anything like this, you will find that it's converted to diesel engine. Okay, do you know why? Do you have any idea? Yes, diesel engines are more fuel efficient. They have higher fuel efficiency. Okay? So they are used for trucks, locomotives, goods transportation and people transportation buses, for the marine applications and the heavy machinery. Okay, because in these applications you will have to run the engine of the vehicle very long times and over very long distances, so fuel efficiency is required. And diesel engines are more powerful than gasoline engines. Okay? So why not use them in passenger vehicles?
They vibrate.
Yes. For the vibrations and the noise levels of diesel engine. You can easily differentiate between a gasoline and a diesel engine if you just stand by them while they are running. You will hear the diesel engine vibrates and makes a very loud noise. Okay? And for passenger applications, what is your main goal? Passenger comfort. Okay? So if you put a diesel engine in a passenger vehicle, it will reduce the comfort level of the vehicle. But if you look in Europe and USA, you will find that lots of Mercedes, BMW vehicles, passenger vehicles, are diesel and powered vehicles. Why is that? First of all, the level of technology for BMW and Mercedes makes their diesel engines less noisy than regular diesel engines. And another thing, that diesel fuel in these regions is much cheaper than gasoline fuel. Okay? It's the same case here in Egypt. Diesel is cheaper than gasoline. The difference in price didn't reach this peak just until the past few years. Approximately in 2010 or 2011, okay, the difference between the liter of gasoline and diesel was 5 pesos only. It was 1 pound for the gasoline and 0.95 for diesel. So the difference wasn't that much. So here in Egypt and in many countries that the difference between the price of gasoline and diesel isn't much. We linked it in our minds that passenger vehicles are gasoline vehicles. Okay? But in other countries where the level of technology is very high in the vehicles, you can find passenger vehicles with diesel powered engines. But they are not that much common. Okay? The most common engines for passenger vehicles is gasoline. Okay? We mentioned these topics last time. If any of you decides to take automotive engineering, okay, you will see this schematic a lot. Because this schematic explains all the major systems in the vehicle. Okay? Starting from the engine, the clutch and gearbox, transfer case and propeller shafts, to the differential, to the tires. You find that the tires have the brake system, the front and rear shafts have the suspension system, the front shaft has the steering system. Okay? So, in the series combustion and internal combustion, we study the engines. And in automotive engineering, we will study everything else inside the vehicle. Okay? So, I just want to differentiate between two main names. There is something called drivetrain and something called power train. Okay? There is a slight difference between both of them. Powertrain is the drivetrain plus the engine. What about the drivetrain? The drivetrain is all the parts that after the engine that makes the vehicle run, that makes the wheel turn. Okay? So the clutch, the gearbox, transfer case, propeller shaft, differential, couplings, everything until you make the wheel turn is called drive train. Okay? If you add the engine to the drive train, it will be called power train. So the drive train is the clutch, gearbox, propeller shaft, differential, and final drive. We talked about this in the previous lecture. Okay? From here we will start to differentiate between gasoline and diesel engines. Okay? Starting from the operating cycle. Operating cycle for the gasoline, it's a constant volume heat addition and it's governed by Otto cycle. For the diesel, it's a constant pressure heat addition and it's governed by the diesel cycle. Okay? For the method of ignition, spark ignition, we use spark plugs. Okay? But in diesel, we rely on compression ignition. Okay? So we rely on making the mixture, or making the air reach the self-ignition temperature of the fuel. So when we inject the fuel, it can self-ignite. Okay? Method of fuel mixing. Did I talk about all of this last time? Or, okay. Method of fuel mixing. We have homogeneous mixture and heterogeneous mixture. Homogeneous mixture means that fuel and air are well mixed, okay, before entering the combustion chamber. It's like the gasoline engine. You inject the fuel, the gasoline fuel, in the intake port, before the intake port. Okay? So the entering air from the intake manifold mixes with the gasoline fuel, and when they enter the cylinder, they still mix during the intake stroke, and when during the compression stroke they are still mixing until you start the spark at the end of the compression stroke. So when the spark is ignited and the fuel ignites, all the fuel is mixed very well with air. So the combustion is homogeneous and all the fuel burns right away. Okay? But in diesel engines, when does the fuel mix with the air? In diesel.
Inside the cylinder.
When exactly?
Recharge.
When?
Before combustion.
Of course. We mix it before combustion starts. Okay. It mixes at the end of the compression stroke. So all the fluid inside the cylinder during the intake and the compression stroke is what? Is air only. Okay? So does any mixing happen during the intake or the compression strokes? No. Okay. The mixing starts when the fuel is injected at the end of the compression stroke. So when the injector injects the diesel fuel, does it have enough time to mix well with the air? No. The mixing isn't well. Okay, you will find areas inside the cylinder with very, very rich mixture, and areas with very, very lean mixture, and areas where the mixture is stoichiometric. It varies inside the cylinder. Okay? This is called the heterogeneous mixture, not homogeneous. The mixture isn't good between the air and fuel. Okay? And this heterogeneous mixture, we will explain the combustion behavior of diesel using this mixture. Okay? For the method of load control, okay? How do we control the load of gasoline engine? We will depress the accelerator pedal, which opens the throttle valve, okay? And opening the throttle valve increases the amount of air incoming inside the cylinder. As the amount of air increases, the airflow sensor, mass airflow sensor of the vehicle measures it. And as we knew in gasoline engines, we are working at stoichiometric combustion. Lambda equals 1. So of course, as the amount of air increases, the ECU calculates the additional amount of fuel required, so it is injected inside at the intake manifold. Okay? So in gasoline engines, we control the load by controlling the amount of entering air through the throttle valve. In diesel engines, does diesel engines have throttle valve? No, diesel engines are unthrottled. They do not have throttle valve. So the amount of air at the same RPM is always constant because there is no valve to regulate the air. So how do we control the load? By controlling the amount of injected fuel. So when we press the accelerator pedal in the diesel vehicle, we control the amount of fuel. Okay? As we press it more, the amount of fuel increases. So do diesel engines operate at constant lambda value? No. At very low loads, the amount of air is the same, and very small diesel fuel amount. So the air-to-fuel ratio is very high. As you depress the accelerator pedal and the amount of fuel increases, the air-to-fuel ratio decreases. But overall, always in diesel engines, the operating conditions of the mixture, it's always lean combustion. Even at maximum loads where the maximum of fuel is injected, it's still lean combustion. Okay? Why is that? Okay, but I can make it that at the maximum amount of diesel fuel, lambda equals 1. Why do I have to make it that lambda is always more than 1? No, it's not like that. I answered it before. It's in the mixing. If lambda equals 1, when I inject the diesel fuel, will it mix with all the air inside the cylinder? Is the mixing good between the air and fuel? No. So I have to increase the amount of air so that I enhance the chances of mixing between air and fuel. Okay? So always combustion is lean. Method of cooling is water or air cooled for the engine. For the injection systems in gasoline, we mentioned that we have carburetor injection and we have port injection. It's like the L-Jetronic, K-Jetronic, Motronic. Okay? And the GDI, which is the direct injection, which is the MED Motronic. For diesel engines, we have two main injection systems. Direct injection and indirect injection systems. Okay? These are the different systems for the gasoline injection, which we previously explained. As for the diesel engine, I mentioned that we have direct and indirect injection systems. For the direct, from their names, direct, we inject the fuel directly inside the combustion chamber over the piston. Okay, as you see in this figure, the right one, the left one, which is direct injection, we inject the fuel directly inside the combustion chamber, the main combustion chamber. But in indirect injection, you see, where did the injector move? It moved up in the cylinder head. Okay? And it injects the fuel inside a chamber which is connected with a small passage to the main combustion chamber. So in the indirect injection, we inject the fuel in a what's called pre-chamber. Okay? So the lecture is about to end, so we'll explain it shortly right now and we'll continue next time. How does the flow in the indirect injection engine happen? During compression, air is compressed inside the main chamber. So where does it go? It moves through this orifice that connects between the main chamber and the breech chamber, and it moves through this orifice and enters the breech chamber. The orifice is a very small passage. So what does it do to the flow passing through it? It increases its speed. So a jet of air enters the breech chamber, and the breech chamber is circular shaped. So when this jet enters the breech chamber, it starts to swirl. Okay? When the swirl is happening, the injection starts. So the fuel is injected inside the breech chamber. Due to the high compression ratio, the air inside the breech chamber is very hot. Okay? So when the fuel is injected, it ignites. So the pressure inside the breathe chamber increases. So what happens to the flow? It reverses its direction. Now the higher pressure is inside the breathe chamber. What does the breathe chamber contain? It contains exhaust, which is burned fuel, and it contains part of the air, okay, and it contains the unburned fuel. And it now has high pressure and temperature. So what happens? All these components inside the breathe chamber move back inside the main cylinder through the orifice. And again, the orifice increases their speed and increases their swirl. Okay? All these swirls that I'm talking about, what does it do to the mixture? Enhances the mixture of air and fuel, which improves the mixing efficiency of diesel and enhances the combustion efficiency. Okay? Does this swirl and mixing that I mentioned in the indirect injection happen in the direct injection? No, you see the injection is exactly right inside the main combustion chamber. So the main difference between direct and indirect injection is the level of swirl. Indirect injection engines have very high swirl, while direct injection have low swirl. Okay? The next lecture we will know what swirl difference makes in the fuel injection system. Okay? Any questions?